Okay, students, so here is our first example. Um, we will first test the population mean with the following problem. The tip should identify whether the test is the population is about the population mean is some of the phrase like the mean or the average. Remember when we do hypothesis testing, it's either about the mean, the proportion, or the standard deviation. Okay, so let's take a look at the example number 1 here. It say that listed below are the measured radiation emission in W-kg corresponding to a sample of cell phone. Use a 0.05 significant level to test the claim that cell phones have a mean radiation level less than 1.0. Okay, so I underlined some information and I circled some information. And as you can see here that I circled the claim so that I will know what kind of claim is being made about this population. And here's the clue to what am I testing about? Am I testing about the mean? Okay, so if you look at these list of numbers right here, this list comes from a sample. Okay, a sample of radiation emission from cell phone. Okay, we're gonna use this sample to test whether the claim that cell phone in general have a mean radiation level that is less than 1.0 kg. Okay, here's another clue that is very important, the term less than. Remember I told you that you have to come up with 2 hypotheses for a test. So if you notice that the first step we have here is to state the null hypothesis and the alternate hypothesis. But before we do that, I would like to make sure that you pause this video and enter this information in the list and try to find the 1-var stat. Okay, because the 1-var stat allow us to obtain some information about the sample. Some of the information we need is the mean and the standard deviation that we need. Okay, so take a moment to do that, and if you already enter that in there, you will be able to see that the mean is going to be 0.09381, and the standard deviation is going to be 0.4228. Okay, so those are the information we need from the sample in order to test the claim. Okay, remember I told you that the null hypothesis is always equal. Okay, so how do we write the null hypothesis here? First of all, we're testing the mean, so we're gonna have the notation mu. Okay, and we're testing the mean of the population. So then the claim is about the population. Therefore, this right here is the mean of the claim about the population. And remember that it must have the equal sign. So I'm going to put the equal sign here and I'm going to say 1.0. Okay. The alternate hypothesis is almost like the opposite of what the null hypothesis is. So because the null hypothesis has the equal sign, then the alternate hypothesis must have this sign right here that we had. So it's going to be the mean less than 1.0. Now, when you write those 2 statements, you will usually be able to see whether the null hypothesis is our claim or the alternate hypothesis is our claim. In this situation, the alternate hypothesis is our claim. So we go ahead and write the claim here so that we know which one is the claim that we're going to go back to. Okay. Step number 2 is to choose and determine a significant level. Well, in this problem, it already gives you a significant level of 0.05. Okay, that means our alpha is 0.05. Okay, if it didn't say in the problem, then use the most common significant level, which happens to be 0.05. Okay, and we also need to find the critical value and the tail test type. I'm gonna do it now so that once we go into more examples, you will understand how it's being constructed. Okay, so if you notice right here that the tail test type has something to do with the alternate hypothesis. So look back at your notes and you notice that the alternate hypothesis has a less than sign. Less than sign means that it's a left tail test. Okay, so I'm gonna go ahead and write here that since the alternate hypothesis is less than, we have a left tail test. Okay, why is this important? Because when I want you to scroll down to step number 4. When you know that you have a left tail test, then you know that your critical value is going to be somewhere on the left side, in which the area here represents our significant level alpha of 0.005. Okay, so we have to find this t right here. By the way, why is it t? Because if you look at the problem here, we do not know about the population standard deviation. Okay, we have to find the sample standard deviation here, which is 0.04228. So since we don't know the population standard deviation, we are going to use the t-test. Okay, so using that information in step number 4 right here, we would need to find what is the critical value here, okay, that represent the left side here at 0.05. Well, if you look into the, we're going to do that in step number 3. So let's go back to step number 2 to find the critical value. Now, since this is a test statistic test, we need to determine the degree of freedom. And if you count the sample size, our degree of freedom is going to be 10 because there are 11 sample in our sample study. And with the degree freedom of 10 and our alpha 0.05, you look in the table, you will see that the T alpha is going to be, since it's the left side, it's going to be a negative. So it's going to be a negative 1.812. Okay. So what is this 1.812? It's something we call the critical value. Okay, critical value. Okay, now step number 3 is when we compute another value called a test statistic. We are going to compare that test statistic with this critical value to make some kind of determination in step number 4. Now, if you look in the notes, because we use the test statistic, you remember the formula for testing the t of the mean. It's t equal to the mean of the sample minus the mean of the population divided by the sample size divided by the square root of the sample size. Okay, so when you input those values, let me input those values for a moment. 0.9381 minus 1.00 equal 4228 divided by the square root of 11. Enter that into the calculator and you get a value called that is equal to negative 0.4587. Okay, this number right here is called a test statistic. Okay, now what do these two numbers mean? What are these critical value and the test statistics mean? Test statistics is on the basis of the sample that we have above here. Okay, we use that to determine the test statistic value. The critical value is on the basis of the fact that we are testing a significant level of 0.05. So right here in step number 4, you should have a negative 1.812 here to represent this line for test statistic. And then if I am going to, not test statistic, critical value, I need to determine where the negative 0.4587 located here. Oh, I have a mistake here. Let me go ahead and erase that. Okay, and so here, since this is negative 1.82, then negative 0.4587 is probably going to be here on the right side. Okay, this value right here is called the test statistic. Okay, so you compare, you see that the critical value is on the left and the test statistic is on the right. Well, another way for me to say this is that the test statistic value fall outside. It fall outside of this critical value region right here. And if you look at the notes on page, let me see, I think on page 2, it say that if you fall outside of the critical value region, we are going to say that we fail to reject the null hypothesis. So the conclusion here is that we fail to reject the null hypothesis. Now, we're always going to determine the null hypothesis. We are not going to determine the alternate hypothesis based on critical value and test statistic numbers. Okay, so remember that. If the test statistic fall outside of the critical value region, we are going to fail to reject the null hypothesis. Now, in order to state a conclusion, I would like you to turn to page 3 of your notes. And I kind of help you in step number 2 here that, oh, not step number 2, step number 3 here, that if you look under the condition, okay, if you look under the condition, page 3 here, okay, you can see under the condition, if the claim, okay, I'm talking about the claim, so we have to go back to that test to find out what the claim is. If the claim does not include the equal sign and we reject the null hypothesis, then this is how we state it. So let's go back to example number 1 and figure out what the claim is, okay? The claim say that we have a less than sign. That means the claim does not have the equal sign. Okay, so let's go back to the notes and figure that out. And also, we also need to remember that we fail to reject the null hypothesis. So the claim does not include the equal sign, and we fail to reject the null hypothesis. So the way that we're going to word the conclusion is going to be based on this, okay, for our example number 1. Okay, so let's state that. Since the claim does not include the equal sign, and we fail to reject the null hypothesis, then we can say that there is not sufficient forget my handwriting evidence to support. Okay, so this is a general way that we write the statement. There is not sufficient evidence to support the claim that, okay? And remember, when we go back up here, remember I underlined the phrase, okay? Let me use a different color to show you what claim that I want to rewrite. The claim that cell phone have a mean radiation that is less than 1.0. Okay, that's the one that I have to rewrite. Okay, so here we have a claim that cell phone have a mean radiation level that is less than 1.0 watt per kilogram. Okay, and that concludes our test for this claim right here. Okay, so we're gonna go to the next example in the next video.